of October and the last day of our FTP program, 7 days of FTP program on first-hand experience on SPSS. And the topic for the today's session is ANOVA content entrepreneurs interpretation. And for this, Dr. Chanchla Jan ma'am, a highly experienced personality, is here with us. As we all know that ma'am is a co-founder of Urja Counseling and Training Indore. Presently, ma'am is working as an assistant professor in Prestige Institute of Management and Research Indore. Ma'am is also the coordinator of IQSC at PIMR and also a research expert and trainer. Ma'am has conducted many more workshops and FDP on SPSS modules, research paper writing and analysis through our programming. Recently, ma'am has completed one research project related to medical field which has been presented before the central ministry. Even ma'am has having the rich experience of more than 10 years in research, and with this, she has more than 42 research papers published in various Scopus, national and international journals. Ma'am has also presented research papers in more than 20 plus conferences and won 5 Best Paper Award at JIMS, Delhi Pacific University, Udaipur, and 3 in Prestige University. 4 research scholars are also pursuing their PhD degree under the able guidance of MAM. MAM has also guided more than 500 plus students in their major and minor research project. And if we talk about as an author, so MAM has also written a book on crucial problem of our society, along with a co-author titled as Atmatya Q. So with this, we all are really luckiest one that we are having opportunity to hear Dr. Chanchla Jan ma'am on RFI's platform. So with this, without any further delay, ma'am, I would like to invite you on behalf of RFI. Now, up next will be your. Please welcome, ma'am.
Thank you so much, Nikita ma'am. So shall I start, ma'am? I think only 4 5 students.
Sure, ma'am.
Yes, 4 5 participants have just joined. So do I need to wait or shall I start?
Okay, ma'am, we can wait for 2 to 3 minutes, then
Yeah.
we can.
Yeah, fine. Thank you.
Okay, ma'am. Okay, ma'am.
Nikita ma'am, shall I proceed now?
Sure, ma'am. Sure,
Yeah.
please.
Thank you, ma'am. So very good evening, everyone.
Very good evening, ma'am.
Good evening, ma'am. So I think I can start. Nikita ma'am, I think the topic you said, ANOVA, I think I covered that yesterday. I forgot
Oh,
that
sorry, ma'am.
no problem. So today I'm taking the regression. That was the last topic, correlation and regression.
Okay, ma'am.
Yeah. So everyone, I hope you people are ready today. We can start now. So the session is today will be on correlation and regression. So as a notes, and I'm just sharing my screen and we'll discuss the conceptual aspect of correlation and regression, and then we will see how we can perform these two using the SPSS, right? So I'm just sharing my screen. Yes, whether the screen is visible or not.
Yes, ma'am, it's visible.
Yeah, thank you, ma'am. So today is the day 7. Although so this topic I need to take tomorrow, yesterday, but I think I have taken ANOVA previously. So today I'm talking about the correlation and regression as a last topic of this FDP. So starting with the correlation first. In the agenda, you can see today I'm going to discuss correlation, types of correlation, assumptions of correlation, and regression and its assumptions. Right. So starting with the correlation. I think when I say correlation, many of you already understand the term correlation or the meaning of correlation. Because from the term itself, we are knowing the meaning of correlation. Correlation is the relationship between the variables, right? Because in statistics or in research, we are dealing with the variables, and that way some of the cases or for some of the objectives, we need to find the relationship among the variables. So correlation is that particular statistical tool which can help us to find the relationship between the variables. So you can see I have written it is very important statistical tool in statistics. Reason to write this is very simple, because correlation is a kind of prerequisite for many of the studies or many of the statistical tools, right? So if you will go for the advanced level statistical test, you previously need to know whether these variables are related to each other or not. So in that case, you need to find correlation, right? So today we are studying or understanding correlation from the particular statistical tool point of view only. But further, if you will apply, like we will go for the factor analysis and all, in that case also you need to find whatever number of items you are taking on a scale, whether they are related to each other or not. So there also we need to apply correlation, right? So it is a very important measure to find for undertaking variables, because if variables are not related to each other, then then other test is meaningless to perform. So this is the basic reason that why we are finding the relationship, because if variables are related, so in that case further types of advanced statistical tests can be performed on such variables, right? So that is why I have written it is a kind of building block in statistics, right? So if you can see that here I have written like mean, standard deviation, and correlation. So if you, I think I discussed already the t-test. So there you have seen that formula of the t-test is based on the mean and standard deviation, right? All the mean and standard deviation comes under the uh, descriptive statistics. There is also we can keep correlation in the case in the descriptive statistics part. So these three different measures can help us for the conducting further advanced statistical tests, right? Talking about exactly, if I talk about the meaning of correlation, so correlation can help us to find the extent, that is the degree of relationship between the two variables. That means up to what extent two variables are related to each other. This is what we are finding using the correlation. And whenever you are listening or hearing the word correlation, the meaning is very simple. We always want to find the linear relationship between the two variables, whether the two variables are linearly related to each other or not. So what is the meaning of linear relationship? Meaning is, if I'm changing one variable by a particular unit, so the same proportion will be occurred in the other variable. So that way it is maintaining the linear relationship. When that means I can say when the proportion of change in both the variables is same. In that case, this kind of relationship is known as the linear relationship, right? So one example you can see, it is written like, when we are talking about the students or their academic performance, so we are generally understanding when the students are putting more efforts in study, generally they are learning more or they are performing better. So this kind of correlation is known as positive correlation. Further, talking about types of correlation. So usually in statistics, there is wide range of correlation available, like simple correlation, multiple correlation, partial correlation. Then apart from that, positive correlation, negative correlation, right? So here I have only mentioned the two correlation, positive and negative, because these two are very important to understand whenever you are going to interpret the results of correlation, right? So as you can see, when I talk about the positive correlation meaning is when the change of direction in both the variables is same. That kind of correlation is known as positive correlation. So there you can see, using this particular graph, which is indicating, you suppose x and y, there are two variables available, and when we are plotting their values on a graph, and when we are fitting a line between these two, this is known as the linear relationship, and this is a positive relationship because it is going upward. This kind of correlation is known as positive correlation, right? Then negative correlation is when the change of direction is not same. You are increasing one, other variable is decreasing, or you are decreasing one, other variable is increasing, vice versa. So in that case, this correlation is known as negative correlation. So when you will look at the graph, you can find this thing. This is indicating this is a downward kind of line we are getting. That means this is a kind of negative correlation between the x and in the y variable. So one example I have taken here for the positive correlation, number of hours study done by the student and the marks he scored. Then that means this is a kind of positive correlation. Second is the negative. I think this is very well-known concept of economics, demand and price. And I think we have also experienced this example in our daily life, right? Generally, when the price increases, demand decreases. So here you can see the relationship is kind of negative. One variable is increasing, other is decreasing. That is known as negative correlation. And suppose when you are plotting the data on the graph using x and y axis, if such kind of distribution of data is coming, this is a simple meaning that your data is not showing any kind of relationship, right? So this way, these are the important understanding about the correlation, because looking at the means it can be a graphical representation of the correlation, or using any particular measure we can understand what is the meaning of correlation, right? Apart from this, I try to take the arrows. Using that also you can understand, if I'm increasing x, y increases. If I'm decreasing x, y decreases. This is a kind of positive correlation, because here the change of direction is same. X is increasing, y is increasing. X is decreasing, y is decreasing. So this is a kind of positive correlation. Then negative is when you are increasing x, y decreasing, or vice versa. When you are decreasing x, y is increasing, is known as negative correlation, where the direction is not same, right? So this is the types of correlation. I hope till here I am clear to everyone. Any doubts so far?
Yes, ma'am, it's clear.
Yeah. Thank you, ma'am. Further moving ahead, talking about how we can measure the correlation. So there is a term, I think many of us already know this thing. This is generally known as coefficient of correlation. So to measure correlation, we are having a coefficient which is given by Sir Carl Pearson. Using this coefficient, we can get the value of correlation. And that coefficient of correlation indicates the strength of the relationship between the variables. So the correlation can help us to find the strength and also the degree. Strength and degree almost similar, right? So using the coefficient of correlation, we can find the strength, degree, and also the direction of the relationship between the two variables. So whenever you are talking about coefficient in statistics, generally coefficient meaning is it is unit free, right? Because it's a coefficient, it's a ratio kind of thing. So it will be always unit free, and this is expressed in the form of percent, if you can say, right? So this is known as coefficient of correlation. Now, talking about the interpretation part of the correlation. So looking at that table, you can understand that how you can interpret the coefficient of correlation. So I am reading this table from the first line, which is indicating R is equals to 0. That means when the value of R is coming 0, because coefficient of correlation represented by small r, which is the coefficient of correlation given by Carl Pearson's. Right? So this way, if you find R is 0, it indicates there is no correlation between the variables. When the R varies between 0 to 0.3, it is low correlation. Between 0.3 to 0.5, it is moderate or average correlation. Between 0.5 to 0.7, above average correlation. 0.7 to 0.9, high correlation. And above 0.9 is known as multicollinearity. So I think if this is, you can connect. This is what I discussed in the second session when I was talking about the reliability. So there's this term I have used, that is multicollinearity, meaning I'm repeating that when the relationship between the two variables is very high, means when your R value is coming greater than 0.9, that means it is known as multicollinearity, meaning is the two variables are almost very similar to each other, right? So this way you can interpret the coefficient of correlation value. And one more thing here, as I said, coefficient of correlation indicates the direction. So direction, how you can identify? If you are getting the positive value of R, that means this is a positive correlation. If you are getting the negative value of R, this is a negative correlation, right? So here I have not put any plus or minus. It is only expressed in the terms of number, but I think by default it is plus, right? It can be negative also. So if it is negative or positive, you can call it as a low positive correlation, low correlation, something like that. Right, so that way you need to use these terms to interpret the coefficient of correlation value. Is it clear? May I proceed?
Yes, ma'am.
Yeah. Now talking about, you can firstly see this is the source. From there I have taken this table. Here you can see according to the types of variables, the type of correlation varies, right? You need to understand the nature of variables you are having, and then you can decide which type of correlation you need to perform. So here the very simple meaning is when both the variables are continuous, that is numeric variables, so you will perform Carl Pearson's coefficient of correlation. When the variables are ordinal, x and y both are ordinal, you will apply the Spearman's rank correlation. When both the variables x and y are nominal, you will apply coefficient pi, that is lambda. So this way, it is very important to understand what kind of variable you are having, and that way you can define or you can apply the coefficient of correlation. And one thing, usually when I talk about when we go for the advanced statistical test, so generally we are looking for the Carl Pearson's coefficient of correlation that will be possible between the two numeric or the continuous variable, right? I hope it is okay. May I proceed?
Yes, ma'am.
Yeah. Now you can see there are certain assumptions of correlation which we need to check before performing the correlation. So the very first one says both independent and dependent variables should be quantitative. That means it should be a numeric variable, it should be a continuous variable, or you can say it is a kind of variable which can be measured on interval or on ratio scale. This is the first assumption. So both the variables should be continuous or numeric, right? Next says there should be a linear relationship between the variables. So whatever two variables you are taking, you need to find whether the two variables are linearly related to each other or not, right? Next one is the absence of outliers. So there should be no significant outliers in the variable. So this is, we will check only for the dependent variable, right? Next is normality. So the variable should be normally distributed in respective population. So whatever variable you are taking dependent, for that variable you are checking the normality. And one more assumption is there should be at least 30 observations to perform correlation, right? Talking about what a correlation explains, means what is the importance of correlation. Other than explaining the relationship, we can also say this is indicating the variability in the variable, right? So I think that we will discuss when we'll talk about the regression. Next one is it could be base of causation, but it does not guarantee causation. So it is very imperative to understand that correlation is not a causation. Meaning is whenever you are interested to find cause and effect relationship, that means whenever you are interested to see which variable is impacting which variable, that way you cannot apply correlation, because correlation can only guarantee the relationship between the two variables, but it will not ascertain that this variable is impacting the other variable or other variable is impacting the first variable. So this is not possible with the correlation. So the meaning is very simple. Whenever we are talking about correlation, there is no concept of independent and dependent variable. But if we are using the same data for the further analysis, so in that case, you need to ascertain which variable you will take as a dependent variable and which variable you will take as a independent variable. So that is why you need to check the assumptions for the dependent variable. But when we talk about only correlation, in that case, there is no meaning of causation or independent and dependent variables. Now, talking about, there are various different formulae available in the statistics. All the formulae will help you to measure the value of small r. So, although we are not going for the manual calculations, so I'm not discussing these much. Only you can see using this formula, means all the softwares are based on this formula only, and that way it is giving us the results of small r. So I think this way you can calculate the R if you are having the value of your X and Y variables. So manually you can calculate the value of R. Talking about how to perform correlation in SPSS, this is the way of performing correlation in SPSS, right? So I think further moving for the regression, we will start or we will understand firstly the correlation using the SPSS. I hope till here I am clear to everyone. Any doubt so far? Yes.
No, ma'am, we can proceed further.
It's clear, ma'am. Yeah, thank you, ma'am. So I'm just sharing my screen for the correlation. I think I shared the same with all of you. I hope you have received on a WhatsApp. I hope my screen is visible.
Yes, ma'am.
Yes. So there you can find I have taken two variables here, advertisement and the sales. A very small data set I have taken here to make you understand the correlation. Right? So I hope it's visible to everyone. Now I'm talking about, as I'm having two variables, right? Which is advertisement and sales. You can check them in a variable view also. So you can find both the variables here listed, and I have taken their measure type as a scale variable, right? Means interval scale or the ratio scale variable, these two are, right? Coming to the data view. Firstly, you need to identify, you need to have two numeric variables. So I think it is not mentioned. I do not need to mention this thing here. We know this thing, advertisement and sales both are numeric here. Is it fine? No doubt?
Yes, ma'am.
Yeah. So this way we have checked the first assumption. Second assumption was talking about the linearity of the variables. So to check the linearity, what you need to do, you need to go to the graphs menu, and there you need to select the chart chart builder. I hope you have located this. May I click on the chart builder?
Yes, ma'am.
Yeah. Once you are clicking on this, just I need to keep it aside. Now what you need to do, you can see at the left side your variables are listed. At the bottom section you can find all the graph names are listed at the left side, right? You need to select the specific graph which you want to display. So I am selecting here the scatter plot. Once you will click on the scatter plot, all the available types of scatter plot will be visible at the right hand side, right? So you need to pick only the simple one. So what you can do, You can double click on this, or you can drag and drop this in this preview area like this. Done?
Yes, ma'am.
Now, X and Y variables you need to shift. So I think there is a concept when we are talking about the regression. We know this thing, X variable is generally known, X axis is generally known as the independent variable axis, right? And Y axis is generally known as the dependent variable axis. Although in correlation there is no meaning of finding independent and dependent, but for the purpose of a scatter plot, you need to choose here the independent and dependent variable. So can anyone tell me which variable can be the independent here and which can be the dependent?
Ma'am, please repeat the question.
Okay.
Ma'am, sales would be dependent and advertising is independent.
Very correct. Sales will be the dependent variable and advertisement will be the independent variable, because we know this thing. Generally, companies are investing so much amount in the advertisement, and the purpose is very simple. They want to increase the sales. So that way, we generally want to see if this much is the investment done in the advertisement, what will be the impact on the sales, right? Is it okay?
Yes, ma'am.
Right. So you need to shift your advertisement variable on a x-axis. I hope done.
Yes, ma'am.
Shift the sales on the y-axis. Done. Done, everyone?
Yes, ma'am.
Now, after doing this, you need to only press on the OK button, and that way you would be able to see the output in the output viewer. I hope it is visible, the output.
Yes, ma'am.
How many of you have generated the same like mine? I don't know how many of you are performing. Okay, Bhavna ma'am, I think performing. Fine.
Yes, ma'am.
Now you can see whenever we are talking about the scatter plot, so scatter plot is a graph which can help us to assess the relationship between the two variables. Means this is a graphical way of finding the correlation between the two variables. So looking at this particular graph, you can find there different data points are scattered here. And if I will see that there is a pattern, like a line pattern is there, but still there can be some deviation, right? So what you need to do, double click on this. Done.
Yes, ma'am.
So once you will be on a chart editor, you need to find the lower bar which is containing various types of graphs, right? So suppose I am picking this one. This is the means fifth from the left and fourth. I think it is a middlemost. This one, right? Add a fit line at total. I hope you have found.
Yes, ma'am.
So there you can find by default it is taking linear, but if it is not taking, you need to set it as a linear because we want to see the linear relationship between the variables, right? And then you can close this. You can find the line is available here and you can close this line as well. You would be able to see now. I hope it's visible. The line is visible to us, and that way we can see this thing that almost the data points are fitting to the line. There is some deviation from the line although, but it is a linear relationship. So we can say that variables are going upwards. This is a kind of positive relationship between the two variables. Is it clear?
Yes, ma'am.
Yes. So what was the next? I think normality and the outliers, right?
Yes, ma'am.
Absence of outlier and normality. Right. So now for checking the next two assumptions, you need to go to the analyze. You'll go to the descriptive statistics and then you will go to the explore. Right? May I click on explore?
Yes, ma'am.
Yeah. Here, you need to shift the variable which will be dependent in nature. So I think we have just discussed. We will take sales as a dependent variable. So you need to shift only the sales in the dependent list box, and then you need to click on the plots. There, I am deselecting the stem and leaf, selecting the histogram, and selecting the normality plots with tests. It is okay, fine.
Yes, ma'am.
Fine. Press on continue. Now you need to press on OK to get the output. There you can find we are having 30 observations, right, for the sales variable. No missing value, total is 30. Coming to the descriptive statistics, mainly you need to look at the skewness and kurtosis. Somewhere you can find skewness is nearby 0, but it is negative, and also kurtosis is negative, right? Coming to the test of normality, which is the Shapiro-Wilks test, the p-value of the significant value or the p-value of this test is 0.018, which is less than 0.05. Is it clear? So what conclusion we will draw here if it is less than 0.05?
We are going to reject null hypothesis.
We will reject null hypothesis. Very correct, ma'am. So if we are rejecting, so conclusion will be
Correlation is very less.
oh, no. We are not talking about correlation right now. We are talking about
Normality. The data is not distributed normally.
Yeah, data is not normally distributed because we are not holding the null hypothesis of the Shapiro-Wilks, right? Coming to the histogram. So histogram is also indicating that it is not showing a proper distribution of the data. Going down, QQ plot is also having a problem. You can find it is showing it is a kind of negative, what I can say, skewness and kurtosis value it is indicating because the curve is coming at the right side of the graph. Going down, talking about the outliers, you can find there is no outlier available in the data. Either if I will look at the lower whisker, beyond the lower whisker or beyond the upper whisker, in both the cases we can find there is no outlier available. So this way you can check the assumptions of the correlation. Assumption checking is clear?
Yes, ma'am.
Fine. Now, how to apply correlation is you will go to the analyze, go to the correlate, and then you can select bivariate. I hope you selected and located this.
Yes, ma'am.
So after that, what you need to do? You need to go to the bivariate. A box is coming. There you need to shift your both the variables in the variables box using the arrow key. It is done. It is done.
Yes, ma'am. Now it's done.
Yeah. In the options you can find nothing meaningful is there. Means if you want to find the mean and standard deviation of your variable, if you want to find cross product deviation and the covariances, that way you can check these boxes. For missing value, it will remove the missing value pairwise, right? If there will be any missing value. Press on continue. So here there is nothing you need to do. Coming down, you can check here. The first section is talking about correlation coefficient, and there you can find there are three variety available: Pearson's, Kendall's tau, and the Spearman. So this is for the numeric variable, this is for the nominal variable, and this is for the ordinal variables, right? So we are having the two numeric variables. So by default, we will go with the Pearson's, and always SPSS will give you the by default selection as Pearson. But if you want to make changes, you can select the other checkbox, right? Coming to the next, which is talking about test of significance. So whether you want to perform the correlation for the two-tailed test or the one-tailed test, that you need to decide. By default, it is taking two-tailed, and if you want, you wish to find for the one-tailed, you can select this also. So up to you. but I'll go with the two-tailed test, right? Then next one is the flag significant correlations. So if any of the correlation value is, suppose one correlation value will coming, if the correlation value is significant, in that case there will be a asterisk sign. Flag meaning is there will be a asterisk sign, right? So this way nothing you need to do, only you need to shift your variables from the left box to the right box, and you need to press on OK button to get the output. I hope it is clear.
Yes, ma'am.
Fine. Click on the OK to get the output. So once you are pressing OK, I hope you would be able to see the output is coming there. Output says that advertisement and advertisement. That means if you will find the correlation between the same variables, it will come 1. But when you want to find correlation between advertisement and sales, it is coming 0.862, and double asterisk we can find. The significant value, that is the p value, is 0.000, which is less than 0.05, right? So you can find double asterisk meaning is correlation is significant at 0.01 level. That means at 1% level, the correlation is significant, right? Is it clear? So we can say this thing, that there is a significant correlation between the advertisement and the sales. Is it clear?
Yes, ma'am.
Now looking at the value, if I want to find, because as I said, it will tell you the strength of the relationship, that is degree, or also the direction. So the sign is positive, right? So it's a positive correlation. And if I'm talking about the strength of the relationship, I can say it is a strong positive correlation between the advertisement and sales. That means 1 unit change, if I will make an advertisement, sales will increase by this 0.862 units, right? Is it clear?
Yes, ma'am.
Anyone asking something? May I proceed?
Yes, ma'am.
Fine. So this way, I think we have checked assumptions and the correlation value using the SPSS. Now, I'll talk about the next concept, which is regression. So I'm sharing now the slides. I hope slides are visible.
Yes, ma'am. Visible.
Yeah. So there you can see, here I'm talking about.
Now they are not visible.
Not visible?
Not okay.
Just a minute. I need to check. Yeah. Just a minute. Again, I'm sharing. Visible now?
Yes, ma'am.
Yeah. Talking about now, the next concept, that which is the regression. So regression is a step ahead from the correlation, where we are interested to find the cause and effect relationship between the variables. There the regression comes in picture, right? Or I can say, wherever you want to forecast or predict the dependent variable using the independent variable, you are talking about the regression, right? So the beginning of cause and effect relationship starts with the linear regression. Linear regression meaning is very simple. That means two variables are linearly related to each other. That means there is a same proportion change will be each variable. So that means it is sharing the linear relationship between the two variables, right? This is known as linear regression, right? Linear relationship means when we increase independent variable with the certain amount, dependent variable will also increase with the fixed amount. Proportion value will be same. This is known as linear regression or linear relationship. Is it clear?
Ma'am.
Right. Yeah.
Ma'am, in this sense, can we say that 5% increase in price leads to 5% decrease in demand?
Yeah, proportion will be changed, same, ma'am. It can be 10% also, because suppose. Hello?
Yes, ma'am.
Yeah. So I think, as you say, 5% increase in the price. So unit change, say for example, if I'm saying 1 unit change I'm making in the demand, or 1 unit change I'm making in a price. So 1 unit change will be there in the demand also. So proportion will be same. That is linear.
Okay.
Right? Now further, if we can quantify the every unit increase in the independent variable, what would be the increase or decrease in the dependent variable? Then we get the linear relationship between the two variables, right? So whatever variable means two variables I am having, one independent, one dependent. So one variable will be the cause, another variable will be the effect. So the dependent variable will be the effect variable, and independent variable will be the cause variable, right? So whenever we are talking about regression, so usually there are varieties available in the regression. But in the case of linear regression, there are simple linear regression and the multiple linear regression. Simple linear regression meaning is what? We will be having only two variables, and one variable we are taking as a dependent and other variable we are taking as a independent, right? When we talk about the multiple linear regression, there we will be having only one dependent variable and more than one independent variables, right? So the type means the nature of the variable should be, when we talk about the simple linear regression, so the variable nature should be, both the variables should be measured on the continuous scale, means both the variables should be numeric in case of simple linear regression, right? So when you want to predict a numeric variable using the other numeric variable, you are using simple linear regression. How you can formulate the hypothesis? So I have taken the hypothesis in the form of advertisement and sales only. So there you can find, if I can write the regression hypothesis in many ways. So I tried to jot down few of the ways. The first says advertisement is not related to sales, or I can say there is no significant relationship between the advertisement and sales, or there is no significant effect of advertisement on sales, or I can say there is no significant influence of advertisement on sales, right? So means there are various ways of framing or formulating a hypothesis, but all the hypotheses will lead to the same meaning. Is it clear?
Yes, ma'am.
Yes, ma'am. Talking about the assumptions of the linear regression, you can find here. First one is both the variables should be measured at the continuous level. Means the scale of a variable should be either interval or ratio. Means your variables should be numeric, both the variables, right? Then there needs to be linear relationship between the two variables. So whatever two numeric variables you are taking, you need to assess the relationship between them, that should be linear in nature. Talking about there should be no significant outliers. So can anyone say this thing? If I am talking about there should be no significant outliers, what is the meaning of this? For which variable you will find this significant outlier value? Yes.
Here we are taking advertisement and sales now. I think we'll see advertisement on dependent variable the same.
Advertisement is not an independent variable. Advertisement is not a dependent variable. It is independent.
Oh, sorry.
Sales.
We check on sales.
For sales, we will check the significant outliers for the sales. Very correct. Thank you, ma'am.
Ma'am, what is outliers, significant outliers, ma'am? Maybe I missed it.
Okay. So I think we are checking, I think from the t-test I started this thing. So you have checked when we are talking about the explore option, there we are finding the box plot, right? So in the box plot, we can locate the outliers are available or not. So I think I talked this thing, either of means beyond your whiskers. So I think you are knowing the shape of the box plot. There will be a box and then there will be lines and mudra sides. So these lines are known as whiskers. So beyond these whiskers, if certain data points are falling, they are known as the outliers. But some of the data points will be near to your whisker. They will be insignificant outliers, right? But when they are going very far from your whiskers, they are known as the significant outliers. And in SPSS, you can find outliers are coming in a circle form and in the asterisk form. So circle outliers are insignificant and the asterisk outliers are significant outliers. Clear, ma'am?
Yes, ma'am. Yes, ma'am. Thank you, ma'am.
Thank you, ma'am. Next one is the residuals of the regression should follow a normal distribution. So, firstly, we need to understand the meaning of residuals. I think everyone in the meeting is knowing this thing. What is the residual? So, residuals are nothing but this is the error term. Meaning is that, as I said, using the regression, we want to predict our dependent variable, right? So, suppose as we are having the sales, we are having the advertisement. So, I want to predict the sales using the advertisement amount, right? So that way, whatever the sales I'm predicting using the regression model, now I need to see whatever is the actual sales. So I need to find the difference in the actual sales and the predicted sales. So if whatever difference is coming there, that is known as the residual. Is it clear? So that residual you need to check that residuals should be normally distributed. And how you can check those residuals? That deciles are normally distributed, you can use the normal PP plot, that is normal probability plot you are using to check the normality of your residuals. Next one is there should be absence of multicollinearity. So absence of multicollinearity, I think I explained. Variable should not be strongly correlated, means it should not be, a value should not be greater than 0.9, right? So how you can ascertain that variable is not having the, or there is absence of multicollinearity, you can check using the VIF value, that is the variance inflation factor. So this value should be less than 10. So threshold value is less than 10. So this is, I mean, the assumption 5 is applicable in case of multiple linear regression. In case of simple linear regression, where we are having only the one independent variable, so there is no logic of finding multicollinearity. But when we are having multiple independent variables, so we need to check all the variables, dependent variables should not be highly correlated. And that we will ascertain using the VIF, variance inflation factor. your dependent variable in the dependent box, independent in the independent box, right? So advertisement is independent, so you can shift in the lower box. Sales is dependent, that you can send in the dependent list box. By default method will be enter. So we will go with the enter only, because we are not going for the multiple regression. So we will only keep it as a enter, right? Further, you need to click on the statistics button. So I think, may I click on statistics? Everyone has shifted the variables.
Yes, ma'am.
Click on the statistics button. There you need to select this Durbin boxen, and if you want to find the descriptive statistics, that also you can select. Done? Done?
Yes, ma'am. Yes.
Collinearity diagnostic, this will give you the VIF value. So I think it is not meaningful right now, because we are performing the simple linear regression and we are having only one independent variable. This is applicable when we will be having more than one independent variables. But still, to show you, I have checked this, right? Then you can press on the continue button. So may I press on continue?
Yes, ma'am.
Yeah. Then you can select the plots. Then everyone?
Yes, ma'am.
Yes, ma'am.
So Z predicted value you need to shift on the x-axis. Z residual value you need to shift on the y-axis. This will give you the scatter plot of the residuals, right? So you need to select here the normal. So this will give you the normality plot and normal PP plot. So you can select the checkbox of the normal probability plot. Done?
Yes, ma'am.
Press continue. Then click on the save. There, if you want to highlight the influential value, so generally it is used by these three methods. I am using Cook's method. So you can select here the Cook's checkbox. Done?
Yes, yes.
Then you can press continue.
I like you.
Click on the options.
You don't like me.
Here, nothing you need to select. Whatever is the by default, we will go with that. So 5%. I think this is for the probability of F. So that will be giving you the ANOVA values, right? So you can click on the continue. Rest all will be as it is. You need to only press on OK. So may I press on OK?
Yeah, ma'am.
Yeah. So once you will do OK, you would be able to see the various tables are coming in the output viewer for the regression results. Starting with the first, which is the descriptive statistics. So for sales and advertisement, we are getting here the mean and standard deviation value along with the size or the number of observations. This is the very basic thing. I'm shifting to the next table, which is the correlation. So if you can recall, I told you this thing. Correlation is the precursor of the regression. So means either we have not performed correlation initially. In the case of regression also, you can find the value of correlation or the table of correlation. So there you can see in the sales and advertisement, we are having 0.862 value coming as a correlation value. That means here it is a 86.2% correlation between the sales and advertisement, right? And it is a positive correlation and a strong positive correlation. It is clear.
Yes, ma'am. Clear.
Yeah. Next one is which method we have used to enter the variables. So we have used the enter variable and we have entered the advertisement variable in the dependent list, right? Next one is the model summary. In model summary, you can find we were having the R and R square value, and then adjusted R square also we are having. So R is nothing but it is 0.862, which we have got here. The same R we will get here, right? Now R square is the square of this, which is what? This is indicating the variance in the dependent variable. So it means whatever percent variance is explained by the independent variable in the dependent variable. So I'll make it like this. I can say 74.3% variance in sales is explained by the advertisement variable. Is it clear? Means advertisement is making change around 74.3% in the sales.
Yes, ma'am.
Right. Talking about the adjusted R square, this you don't need to report when you are talking about the simple linear regression. This will be used in the case of multiple linear regression. And one thing is this, that always the adjusted R square will be less than to your R square value. Is it clear?
Yes, ma'am.
Then talking about the Durbin box set, which is ascertaining your residuals are independent or not. So I told you this value should be less than 2, which is coming here 1.31, right? So that means we have achieved that assumption of the independence of the residuals. Talking about the ANOVA table, I think yesterday when I was talking about the ANOVA, I told you this thing. In the regression also, we are getting the results or we are getting the table of ANOVA. So the purpose is here, ANOVA table will ascertain the fitness of the model, whether your model is a good fit or not. So for that, you need to find the significant value of the ANOVA, which is less than 0.05. So we will say this thing that when the ANOVA is less than the level of significance, we can conclude that model is a good fit. Is it clear?
Ma'am, please repeat, ma'am.
Yeah. For finding the fitness of the model, whatever model we are fitting here in the regression or using the regression, you need to check the fitness of that model. So that we are checking using the ANOVA table, and there you need to find the significant value. This value should be less than 0.05. If your level of significance is 5%, so this should be less than your level of significance. So if it is less than of your level of significance, that way you can conclude that your model is a good fit.
Yes, ma'am.
Right?
Yes, ma'am.
Next one is the coefficients. There you can find that the beta, if I'm talking about the unstandardized coefficient, there you can find B is written. So you need to see the constant value, which is the A, 5.804. And the advertisement value is advertisement coefficient, that is the value of B, is 1.220. But unit, this is the value given by the regression output. But you need to ascertain whether these two values are significant or not. Mainly, you need to ascertain the coefficient of advertisement, because this is a constant value, right? So you need to check here that you will ascertain using these two columns, that is the T and its significant value. So you can find the significant value for this constant value is 0.000, which is less than your level of significance. So you will conclude that this constant is significantly contributing to your sales variable. Similarly, talking about this is also less than your level of significance. We will conclude that the coefficient of advertisement is significantly contributing to the sales, right? So if I will change sales by advertisement by 1 unit, so the sales will change by 1.22 units, right? When the constant is 0. Is it clear?
Yes, ma'am.
Yes, ma'am.
Right. Going down, you need to see the PP plot, normal PP plot. So here you need to see, this is the fitted line and all the residuals are what I can say distributed along the line. But all the data, all the residuals are not exactly coming on the line, but still they are little nearby to the line. So somewhere we can say that the residuals are approximately normally distributed. So this was also one of the assumptions of the regression. If you can recall, I discussed this, right? Coming down, scatter plot, this will understand or this will help you to ascertain the homogeneity of the variances of the residuals, right? So what you need to do? Do a double click on this. Did everyone? Done, everyone?
Yes, ma'am. Yes.
Now select the same that fit line at total, and there you need to select mean of y. Done?
Yes, ma'am.
Click on apply, then close, and then close. So this way you can find, if you can see this comment, I'll show you here also. This is, you need to see this type of graph we have made here now. So now you can see here the point almost equally distributed both the sides of this middle line, right, which is the mean of the y. So that way you can conclude this thing that there is no what I can say formation of the shape in the residuals distribution. So that way we can conclude this thing that the homogeneity of variance is maintained by the residuals. Is it clear?
Yes, ma'am.
Yeah. Any questions, sir?
Ma'am, can you explain how did you done this line? Like I have done up to this step
Double click.
to the graph.
You
Okay.
need to go on this line. That is add
Okay.
to a fit line. There in
Okay.
this, you need to select this mean
Okay.
of y. Fine.
Okay.
Then you will click on apply, and then you can click close this particular chart builder. You would be able to see the line.
Okay.
Fine.
Yes, ma'am. Yeah. Thank you.
Now I need to show you one more thing. I think initially yes. This is, you need to check. I think coming afterwards, once I will form the model for you. Yes. So we will form a model here using this data. So what I am doing here. Yeah. Now, can any one of you tell me what will be the model line here in terms of sales and advertisement?
Sales is equal to A is not
No, fine, no problem. A plus B.
B into advertisement plus E. That
Yeah. This is the line. E we are not taking right now. We are just taking the main line here, right?
okay.
This is the line we have taken. We want to predict sales, right? So I think A we have found here. Now you can see A is 5.804. I am writing 5.804 plus. B is what? It is 1.22, right? So it's 1.22 multiplied by advertisement. Done?
Yes, ma'am.
So this is the line which we have fitted. Now if I will keep any value of advertisement, suppose companies decided to invest, suppose 1 lakh rupees. So 1 lakh I'll multiply by this, I'll add this, that way I can predict the sales of a company. Getting me?
Yes, ma'am.
Whatever will be the actual sales, you can take the difference of those and you will get the residual. So if difference is very less, right? If difference is very less in the actual and the predicted sales, so that way it is indicating your model is a good fit. Clear?
Okay, ma'am. Yes.
Right? Yes, ma'am. So what I want to show you here is that here. So when we have plotted a scatter plot and we have fitted this line, so you can see same line we are getting here. Visible, I hope.
Yes, ma'am.
Right? So means scatter plot, if you are fitting a line, in that way also you are getting the line, but how to find these values in a regression, that we have seen. Is it clear?
Yes, ma'am.
Right. So any doubt in the interpretation part? Everything is clear? No doubt?
No, ma'am, it's clear.
Yeah, one more thing I think I need to tell you, that is the VIF. I already told you this is not applicable in case of the simple linear regression, but if you are having the multiple variables, multiple independent variables, in that case you need to report this, and in that case you need to check whatever is the VIF values coming, you need to compare that with the 10. Hello, I'm audible.
Yes, ma'am.
Yes, ma'am.
Yeah, sorry, it was a power cut. Yes. So now I'm concluding today's session. So give me a second. Yeah, I'm stop sharing my screen. I'll just conclude the session and the FTP today. So if I talk about the today's session, today we have discussed two concepts. One was the correlation and second one was the regression, right? So when I talk about correlation meaning is, I think I explained you, it is indicating the relationship between the two variables. Using the correlation, we can find the positive and negative kind of correlation, that is strength, and the direction of the correlation we can find using the coefficient of correlation. This is what we discussed for the correlation. We have also seen there are certain assumptions, and then how to check those assumptions, that is also I explained you, right? So the assumptions, like when you need to check normality and outlier, as this is a concluding session, so again I'll repeat that process. You need to go to the analyze, descriptive statistics you will select, and then you will select explore, right? And then using that particular explore button, you will further shift your variables. And the main important thing is that in the plots button, you need to select the normal probability plots, right? And that way you will ascertain or check the normality of your variable. This will give you the histogram, this will give you the box plot, skewness value, kurtosis value, and also Kolmogorov spin now and the Shafarov-Wilks test value. So all type of methods you will get on a simple platform there, and that you can conclude, right? So this way, that way you can ascertain the normality. Then talking about outlier, so I think this is also I told, in the single platform you can check both the things, or in the single box you can check both the things. So that way you can check your assumptions. Then you can easily perform correlation. You can go to the analysis, and then there you can select the correlate and then bivariate. And then after that you can shift your both the variables, and you need to only press on the OK to get the output, right? Output will be very simple to interpret. You need to only see the value of your correlation value. So in the both the variables, you need to check the correlation value. It should be usually, if you want to say that it strong, because generally we are looking for the strong correlation. So it should be above 7 or above 7, right? So if it is coming that, it is good, that you can ascertain whether it is significant or not using the p-value, right? Further, I talked about the second concept today, which was the regression. So in regression, I told you it is a study of the causation, that is cause and effect, or using the regression, we can predict the one variable using the other variable, right? So we have seen today the simple linear regression, and there I have told you that one variable should be the dependent, one variable should be the independent. This is what we discussed. And then I told you the nature of both the variables. So this should be, both the variables should be your numeric or the continuous variable. Also, we have seen for the various kind of scales, which kind of correlation can be performed in the SPSS, right? And then assumptions checking is very important in case of regression. There are multiple assumptions available. Few you can check beforehand, and few you need to check while performing the regression. So there in the regression only you can get all the checking of the assumptions, like assumptions, because most of the assumptions are related to the residual, and residuals will come only once you are testing or you are finding the model value, right? So there you can check the assumptions. So most of the assumptions are talking about linearity of the residuals. Then it is talking about the residuals should be independent to each other, and then residuals should be having the homogeneity of variances. So this is what you need to check, and then you can conclude about your regression model. So there I talked about, firstly you will check its fitness, or that model is a good fit or not, that you can check using the ANOVA significant value, and then using the coefficient value, that is constant, and the value of your that whatever the independent variable you are having, its coefficient value you need to check, and you need to ascertain that both the values should be significant, so that you will ascertain using the significant value of the t-test, right? So this is what I have discussed today. If I will summarize the whole FDP, in the initial day we have talked about the very basic part of the SPSS. We have seen that what are the various, what I can say, firstly we have talked about the interface, then we have talked about the various views of interface of the SPSS, then we have seen how to define the variable there, how to perform the decoding and all. This is what we discussed at the day 1. Then the story or the journey started of the non-parametric and the parametric test. In the non-parametric test category, I discussed the chi-square, and we have seen the 2 categories of chi-square, that is goodness of fit and the test of association or independence of attributes, right? So we have seen how using SPSS we can perform. So if you can recall, for performing both the both the chi-square test, you need to go to the different ways, right? In the one, you will go to the descriptives, and then you will go to the cross steps. That will give you the goodness, that will give you the independence of attributes test, right? Second one was the goodness of it that you can find from the non-parametric test category, right? So this is what we have seen. Further, we talked about the further we talked about the parametric test, and in that category, I discussed the T and ANOVA. So on day 1 of the parametric test, I discussed the only one sample T test. There I have seen, or there I explained you, generally T test is used for the finding the significant mean difference, and there are 2 varieties, 1 sample and the 2 samples, right? So in 1 sample category, we have seen this thing that we will be having a single sample, and we need to compare its mean from the population mean. And population mean will be the mean which will be known to you, or you are hypothesizing is. It is like you are assuming that this will be the population mean, and then you are comparing your sample mean from the population mean. This is what we have seen in case of 1 sample T test. In case of 2 samples, we have discussed independent samples and the dependent samples. In the independent samples, I talked about the variable requirement, 1 categorical, 1 continuous, and we have seen categorical variable should have only 2 categories, right? Purpose will be same. It will find you for, it will give you the significant mean difference in the significant mean difference of the dependent variable, which is the continuous, in context with both the categories of your independent variable. Further, we have talked about ANOVA, which I told you it is the extension of the independent sample status. So there I talked about that how to perform the ANOVA, and then we have seen the requirement. So requirement is almost similar, which we have talked about in case of the independent sample status. So I said we will be having 1 continuous variable, we will be having 1 categorical variable. In categorical variable, you need to have at least 3 labels. More than 3 labels will also work for us, but there should be at least 3 labels, because ANOVA is also finding the significant mean difference like the independent samples T test. And then we have seen various assumptions and checking of them. And I think dependent T test also I discussed. This is known as the paired samples T test. And there I talked about how to perform paired, and mainly when we are talking about the paired sample status, the important thing is that you need to always see this thing. Only you will be having a single variable, right? Single, which variable? Single dependent variable, which you will measuring 2 times. So there will be a sufficient time gap for that particular variable. So I think I have given you various examples. Say for example, a company wants to measure the performance of its employees, right? So company will record the present performance, and then suppose company is introducing a training. So after giving a training, after applying whatever the employees have learned from that training, they will apply that in their day-to-day work, and then after a certain period of time, the company will again record their performance, and then that way it can be compared. So this is a case of the paired sample status, right? So this way, this was the summary or the gist of all the 7 days what I discussed with all of you. It was a very nice journey with all of you. Many of you have interacted with me, like Ketki ma'am and Bhavna ma'am. Sometimes Sujata ma'am and Sayed sir also interacted with me. But remaining people were silent, but I think they were listening to me and performing along with me. So thank you everyone for listening me, patiently learning along with me. I want to extend.
Yes, ma'am, please continue.
Yes, I want to extend my sincere gratitude for the RFI, always giving me a platform to discuss concepts regarding the SPSS on the various topics. So thank you so much, Ajay Jain sir, Saurabh Jain sir, the entire RFI family, and the host Nikita ma'am to be there on time and introducing me with all of you. Thank you so much, everyone.
Thank you so much, ma'am, for such an interactive session you have done with our students. And we are really thankful to you that you spend your precious time in this festive time season on our RFI's platform. So we are really happily thankful to you. And thanks to all your participants also for being very cooperative and patient listeners. I hope, ma'am, we will all see you again on the same platform.
Hope
Thank
to
you
see
so
you.
much, ma'am.
Yes, ma'am. Hope to meet you all.
Thank you, ma'am.
Thank you.
Ma'am, ma'am, it was
Thank you, ma'am.
wonderful to have you, and would like to again attend more of your FDPs, ma'am. Please keep us updated when is your next
Thank you.
FDP.
Thank you so much, ma'am.
Of your activities, ma'am. Please keep on sharing feelings.
Definitely, ma'am, definitely. I think RFI is organizing many a time. So organize, you need to be there in one of the groups of the RFI. So there you can find the further information of the remaining FDPs, right?
Yes, ma'am, they do share.
Yes.
Okay.
Yeah, thank you.
Pardon, sir. Pardon.
Yoga sir is saying that your
Pardon, sir. I don't.
Kalliman sir is saying the certificate will be issued to you on your registered mail ID.
Okay, ma'am. Okay, ma'am. Thank you, ma'am. Thank you,
After
ma'am.
the
Yes, ma'am.
completion,
Received, sir.
within 4 to 5 working days, you will
Okay.
just receive your certificates.
Yeah, it's a festival season. Maybe it can take little longer also, ma'am. So be patient. Be there in a group. You will get an
Oh,
information.
4 to 5 days, no, ma'am?
I
Maybe
got
around
it.
4 to
Ma'am,
5
after
days.
this festival period,
Yeah. It's a festival season. Maybe it can take little longer also.
Ma'am, it is received. RFID. I received the
Okay.
certificate.
Okay. If it is
Okay,
received
I
by
will
you,
check, ma'am.
it is good. If it is received by you people, it is good. But if not received, so sir said within 4 5 days, you people will receive. But it is a festive season, so maybe you can get it as soon as possible. Kusum ma'am has also shared she has received. Thank you. So I may expect you to switch on your camera so that I can capture you. Anyone who can open and switch on your cameras. Kirti ma'am, I can see. Hi ma'am. Nikita ma'am is on shopping. Is it so?
Ma'am,
Yes.
yesterday was my daughter's birthday.
Oh,
So I could not attend the entire session. I tried to join in the beginning and then I could not attend the entire one.
okay. No issues, ma'am. Wish her a very happy birthday from our side.
Thank you, ma'am. Thank you so much.
The good wishes from all of us.
Thank you,
Ma'am,
ma'am.
we have provided you YouTube link, so you can just go through that. So you will just find the recorded lecture of previous day also. So it
Yes,
will
ma'am.
be
Yes,
helpful
ma'am. I
to you for
will.
that.
Yes, ma'am. I will do that. I will do that. Pakka.
Thank
And
you,
it is
everyone.
always lovely to attend ma'am's lectures.
I think we have met Katiki ma'am.
Yes, ma'am. In August also. Yeah, ma'am. In August also.
Yeah, I think I can recall your name. I think we have met.
Yes, ma'am. With
Virtually.
your name only, I joined another session.
Okay, fine. Thank you.
Oh my God, ma'am, it's the biggest. What I can say, nothing can be the biggest one comment more than this. That you are very much fantabulous and famous among all the participants.
Thank you so much, Nikita ma'am, for that kind words. I think it is like if you people are interacting, asking me things, so maybe it is more easier for us to deliver the things. So this is all about that only.
Ma'am, thank you so much for your helping to us. In the first 2 3 days, I was out of station. I was in the bus. I couldn't learn, but in the last section, I learned very properly what you thought. I learned, but now the only some other institution became like a business, like they are offering, but they're not teaching well. I learned very well. Thank you so much.
Yes.
I join with you.
Thank you so
for
much,
this
sir. Thank
courses
you
in
so much.
advance.
Thank you so much, sir. So Ketki ma'am, I think I have seen your daughter. Hi. I captured her also. Thank you so much.
Thank you, ma'am. Thank you. And wishing everyone happy Diwali.
So thank you everyone. Yeah, happy Diwali and happy Diwali to everyone. Happy Diwali.
Wish a happy Diwali to everyone. Thank you so much, ma'am.
Bye, everybody. Bye.
Bye, ma'am. Bye.